Welcome back to the video series on the thin cylinder. Already we have done one video on the circumferential or the hoop strain and the longitudinal strain. Quickly we'll revise this and we'll make a numerical practice based on the circumferential strain and the longitudinal strain. So in the thin cylinder, the state of stress is represented by sigma x, that is the normal stress. Sigma x will be same as equal to the longitudinal stress, and the hoop stress is representing the y. We know that the hoop stress here will be always equal to 2 times of the longitudinal stress, and the value of the hoop stress is given as pressure multiplied by internal diameter d divided by 2 times of thickness. And if you want to convert into 3-dimensional, then you have to give the value of sigma z equal to 0. The sigma h here is a maximum value out of all the 3 stresses here. So sigma 1 will be assigning equal to sigma h. Sigma 2 will be equal to sigma L, that is the principal stresses we are arranging in the increasing order, and sigma 3 will assign equal to 0, that is sigma z value equal to 0. So maximum principal stress same as hoop stress. The second principal stress equal to sigma L, and the minimum value will be equal to 0. In addition to this, we have introduced the longitudinal strain, and the longitudinal strain is same as epsilon L equal to sigma L by E, and basically is defined as the change in length divided by original length equal to L. Epsilon D basically defined as the change in the circumference to the original circumference, and is given as sigma H divided by E, is same as equal to the change in diameter divided by the original diameter equal to d. We can use a generalized Hooke's law to find out the value of epsilon x and epsilon y, and we can use this equation. Using epsilon x, we can calculate here what is the total strain along the x direction. For this one, we have to substitute for sigma x equal to sigma L. Epsilon x will be same as equal to epsilon L. Sigma y will be equal to hoop stress, and we can solve this equation by putting the value of sigma z equal to 0. So this equation can be ready anytime by using the generalized Hooke's law. If you calculate value of epsilon x and epsilon y, then we can also calculate the value of the principal strain. Here the longitudinal and the hoop stresses are the principal stresses. That is, we have epsilon 1 will be same as equal to epsilon y. That is a hoop strain or circumferential strain. Second principal strain we can calculate on the basis of epsilon x. If we know the value of epsilon 1 and epsilon 2, that is the two principal strains, we can calculate the maximum shear strain in the plane. And the maximum shear strain in the plane is represented by gamma max. That will be same as equal to the difference between the two principal strains, that is epsilon P1 minus epsilon P2. So you have to calculate here two principal strain, that is the value of epsilon x and epsilon y you have to calculate. And to calculate the absolute maximum shear strain, we require here the minimum value and the maximum value of a strain. Out of that, epsilon 1 is equal to epsilon y. Along the y direction, we have circumferential strain that will be same as equal to epsilon maximum value. And if you calculate epsilon z using the same equation as 1 by E into sigma z minus mu times sigma x plus sigma y. So if you solve this and you put the value of sigma z equal to 0, so this value will give you minimum value of the three principal strain, and the maximum value is given as epsilon max. So if you know the maximum value and you know the minimum value, then you can calculate here the maximum absolute shear strain. So basically this value is a maximum shear strain in plane. And if you want to calculate maximum absolute, so we have maximum shear strain, but we have absolute value, that will be the difference between the maximum strain and the minimum strain. Maximum strain here is given by epsilon y, and the minimum strain is given by epsilon z. So almost everything you can calculate here. You can calculate the hoop stress, you can calculate here longitudinal stress, then you can calculate longitudinal strain using dl by L. Epsilon L you can calculate from epsilon x, and the hoop strain epsilon d you can calculate on the basis of change in diameter to original diameter or by using the epsilon y equation. Once you calculate hoop stress, longitudinal stress, and the third stress will be equal to 0, so we have to arrange these stresses in the increasing order of principal stresses. Sigma 1 is the highest value, so sigma 1 will be same as sigma h. Sigma 2 will be equal to longitudinal stress, and two-dimensional problem we can convert into three-dimensional problem by assigning sigma 3 equal to 0. If you calculate here epsilon y and there is no shear stress is acting, it means that epsilon 1 is same as equal to epsilon y is a maximum principal strain. Second principal strain we can have epsilon x, that is along the longitudinal axis, and epsilon z will be the minimum value. If you are asked to find out the maximum shear strain in plane, that will be epsilon p1 and epsilon p2 difference. Two-dimensional problem, we have to only consider sigma 1, sigma 2. For that one, we have defined epsilon p1 and epsilon p2. These two principal stress difference will be the maximum shear strain. But if you want to find out the absolute maximum shear strain, then you have to find out the value of epsilon maximum, which is same as epsilon y, and the epsilon minimum is equal to epsilon z. The difference between the maximum and minimum will give you the maximum value of the shear strain. Now, in this video, we'll only practice on the strain calculation and the change in diameter, change in length, and the change in the volume based on the hoop strain and the longitudinal or axial strain. Now we'll take here one general numerical in which we'll find out the maximum shear strain in the plane and the absolute maximum shear strain. It means that you have to calculate the principal strain as well as the hoop stress and the longitudinal stress. A strain gauge is mounted to the outer surface of a thin wall boiler. The boiler has an inside diameter of 1800 mm, wall thickness equal to 20 mm. It is made up of a stainless steel having Young modulus equal to 193 gigapascal, Poisson ratio equal to 0.27. Determine the internal pressure in the boiler when the strain gauge reads 190 microns. This value of, then we have to calculate the maximum shear strain and the absolute maximum shear strain. Internal diameter D is given this time is equal to 1800 mm. Thickness is also given, that is the wall thickness is given, which is equal to 20 mm. Young modulus E is also given, is equal to 193 gigapascal. In addition to this, Poisson ratio is also given. Mu is given equal to 0.27. This figure represents the state of a stress. Sigma x is equal to sigma L. Here sigma h will be same as equal to the principal stress sigma h. We have given here the strain gauge reads 190 micron. That value will treat as a epsilon x value, that is, that value is given along the axis. Is 190 micron is 190 into 10 to the power minus 6. Strain is dimensionless term. In the first part, you have to find out the internal pressure, that equal to P. In the second part, you have to calculate the maximum shear strain in the plane of the boiler, that is gamma max in plane you have to calculate, which one is epsilon 1 minus epsilon 2 will be same as the difference between the two principal strain. Epsilon 1 here will be same as equal to the hoop strain and epsilon 2 will be longitudinal strain. Absolute maximum shear strain you have to calculate, which one is epsilon 1 minus epsilon 3. This is the difference between the maximum and the minimum strain. We have hoop stress, that is sigma h is given as pressure multiplied by diameter is divided by 2 times of T, and we have longitudinal stress is given as pressure multiplied by diameter and is divided by 4 times of T. Since we have given the value of epsilon x, we can apply the generalized Hooke's law. We have epsilon x is same as equal to 1 upon Young modulus E multiplied by sigma x minus mu times sigma y. Sigma x is same as equal to sigma L, which is PD by 40. So we have epsilon x equal to 1 upon Young modulus. Sigma L is PD divided by 40. So we have pressure multiplied by diameter and divided by 4 times of T minus mu. And sigma y is hoop stress, which is equal to PD divided by 2 times of T. Now the pressure, diameter and thickness we can take it outside. that is a common to both. So we epsilon x will be equal to pressure multiplied by diameter divided by 2 times of thickness will take common. So we have 2 times of thickness divided by Young modulus, and now here we are left here with 1 by 2 minus mu. Now let's substitute here. We have epsilon x is equal to 190 into 10 to the power minus 6. Pressure P you have to find out. Diameter D you have to take in mm is 1800 divided by 2 times of T. Thickness is equal to 20. Young modulus you have to take in megapascal is 193 into 10 to the power 3 and is multiplied by 1 by 2 minus Poisson ratio. Poisson ratio is 0.27. You have to solve this equation and we'll get the pressure in megapascal. So we get a pressure P in megapascal is approximately equal to 3.54. That will be megapascal. Once we know the pressure here, we can calculate the hoop stress and the longitudinal stress. Hoop stress is acting along the y direction, so we have sigma y is same as hoop stress, and we have pressure equal to 3.54. That will be megapascal. We have diameter equal to 1800 divided by 2 times of thickness, and we have thickness equal to 20. Solve this, you will get sigma y is 159.3. that will be megapascal, and exactly half of this we have longitudinal stress, which one is acting along the x direction. So we have sigma L is equal to sigma h by 2. Sigma h by 2 is 159.3 divided by 2. So we have 159.3 divided by 2. That will be equal to 79.65 will be megapascal. Now we know both the stress here, and we are knowing the value of epsilon x, so we are ready to calculate epsilon y first, and then we'll calculate epsilon z. We have sigma z in this case will be equal to 0. So strain along the y direction will be equal to 1 upon the Young modulus E multiplied by stress along the y direction minus mu into stress along the x direction plus we have strain along the z direction. We have epsilon y is equal to 1 upon Young modulus is 1 upon Young modulus you have to take in megapascal is 193 into 10 to the power 3. In numerator we have sigma y, and we have sigma y is equal to 159.3 minus mu is equal to 0.27, and sigma x is equal to 79.65 and sigma z equal to 0. So it is multiplied by 79.65. Solve this, you will get epsilon y. So epsilon y will come out to be is approximately, I will write this value is 714.5 into 10 to the power minus 6. Now we'll calculate epsilon z also. So we have epsilon z equal to 1 divided by Young modulus into sigma z minus mu times we have sigma x plus sigma y. This type of numericals are not asked in the GATE examination. This is just a practice for you. So we have 1 upon Young modulus is 1 divided by Young modulus is same as 193 into 10 to the power 3. Sigma z equal to 0 minus mu is equal to 0.27 into sigma x. Sigma x is equal to 79.65 plus we have 159.3. Solve this, we'll get epsilon z. We'll get this value as a negative value, and we have epsilon z equal to minus 334.5 into 10 to the power minus 6. Now out of epsilon z, epsilon y and epsilon x, the highest value here is 714.5. So in this case we have epsilon 1 will be same as equal to epsilon y. Yeah, epsilon 2 will be equal to epsilon x, and the minimum value is the negative value. We have epsilon 3 is the minimum value is epsilon z. Now we can calculate here gamma max in plane. So maximum shear in plane is epsilon 1 minus epsilon 2. Epsilon 1 is epsilon y is 714. We have 714.5 minus epsilon 2 is equal to epsilon x. Epsilon x equal to 190. 10 to the power minus 6 is common. So this represent here the maximum shear strain in plane is 524.5. 10 to the power minus 6 is micron but in radian. You have to calculate gamma max. The maximum absolute shear strain is epsilon 1 minus epsilon 3. We have epsilon 1 is equal to 714.5 10 to the power minus 6. 714.5 minus epsilon 3 is equal to epsilon z is negative. So we have minus 334.5 and it is multiplied by 10 to the power minus 6. This value is close to 1049 into 10 to the power minus 6. That is we have 1049 will be micro radian. In this fashion we can calculate here the maximum shear strain in plane, maximum shear strain absolute value using epsilon 1, epsilon 3, and maximum shear strain in plane we can calculate epsilon 1, epsilon 2. Process is all simple, straightforward. Basic Hooke's law you have to use 3 times to calculate the value of epsilon y, epsilon z. Epsilon x is given. From epsilon x, first you have to calculate pressure. Once we know the pressure, calculate hoop stress, calculate longitudinal stress. Hoop stress is same as equal to sigma y. Sigma L will be equal to sigma x. Sigma z will be equal to 0 because this one is a 2-dimensional problem, and anytime 2-dimensional problem can be converted into 3-dimensional problem by assigning the third direction stress equal to 0. Then you can calculate the value of gamma max in plane and the absolute value. The video you are watching is from the app, which is the Mohod class app available on Google Store, and in this app we'll cover all subjects involved in mechanical engineering for GATE. Join the course directly from your mobile. The link is given here.